Welcome to the Volume of Revolution Washer Method podcast. All right, so this was the problem we were ended with in class. I'm just kind of going to go over this one the rest of the way, and then I have, I think, one more problem that was in the notes, some review, some summary notes, and then I have 4 examples rotating over the x-axis, the y-axis, a vertical line, and a horizontal line. So we want to find the volume of the solid. We talked about, here we have a bowl that's created by this solid rotating. It is vertical, a vertical line of axes, so it's going to be right minus left. So x minus 1 all squared is my outer, and the square root of x minus 1 is my inner. However, since it's a vertical line, this does have to be, the function has to be rewritten to be solved for x. So there we have our outer and our inner functions resolved out for x. Right? And then we had to change the limits to be y values. So there you see now we're using 0 to 1 instead of 1 to 2. Right? So I can go over this again in class. So now I square. So I can't get the whole thing in here because I can't go to full screen and record. So I'm going to have to try to just scroll down. So we square the square root of y plus 1. And we square y squared plus 1. So we have square root of y times square root of y, so it's going to be y. And then I'm going to have the square root of y plus the square root of y, so that's going to be 2 square roots of y. And then, of course, 1 times 1, which is going to be 1. And then we square y squared plus 1, that's going to be y to the 4th plus 2y squared plus 1. And then we distribute that negative sign, and then we can integrate. I'm going to try and scroll up. Right? Let's hold that. Sorry, I can't scroll down and hold on to the microphone at the same time. All right, so we're going to integrate this. So I, of course, rewrote this. Notice we have 2 square root of y. That would be y to the 1/2. It says it right above there. Then we can use the power rule. So when we integrate, we have y squared divided by 2. Plus 2y to the 3/2 divided by 3/2. Dividing by 3/2 is the same as multiplying by 2/3. So that's going to be 4/3 y to the 3/2. And then we have minus y to the 5th divided by 5, minus 2y cubed divided by 3, and then minus y, because we distributed the negative sign. So we plug in, we're up to the plugging in part. So now we have 1 squared divided by 2, plus 4 times 1 to the 3/2 divided by 3, plus 1 to the 5th divided by 5, minus 2 times 1 cubed divided by 3, minus 1. And if I plug in 0, every single one of those terms has a y, so it's just going to be 0. Right, so then we're just going to simplify that. I have that over on the side there. 1/2 plus 4/3 plus 1/5 minus 2/3 minus 1. Looks like part of my 2/3 got erased. And then we just simplified. That would be 11/30 pi. I think I have a decimal equivalent. I think this might have been an AP problem. If it was a decimal equivalent, it was multiple choice. I think it was 0.9667 pi. I would always leave it in terms of the fraction, unless it, of course, is maybe a multiple choice question and it has a decimal. Right? So here's this problem. All right, let's look at the next problem. Want to find the volume of solid generated by revolving the given region about the y-axis. So here we have another vertical one. Hopefully this is different than the one I did, I can't remember, on my extra problem. If not, I'll have to quickly write a new problem. So it's y equals the square root of x and y equals x, and we're revolving that around the y-axis. I think we saw the same graph revolved around the x-axis. Here we get a little bit different shape. And they switch who's going to be right and left. Who's going to be upper and inner, depending on whether I'm going over the x or the y. So on the vertical, it's the one to the right, x equals y, because it has to be rewritten and has to be written in terms of x. X equals y is the outer function. That one's to the right, and then x equals y squared is the inner function, because that one is to the left. And of course, to get x equals y squared, we just simply square both sides. We square both sides to get rid of the radical, and we have y squared equals x. All right, so then we're going to square it, outer minus inner, and then we'll integrate and evaluate. So we have y squared. Where's our function? So we have x equals y is the outside, so we have y squared, and then we have minus y squared squared, so that's going to be y squared minus y to the fourth. An easy integration and an easy evaluation. Y cubed divided by 3 minus y to the fifth divided by 5. Integrate that from 1 to 0. If you plug in the 0, of course, that'll be 0. So we're going to have 1/3 minus 1/5 times pi. A common denominator there is 15, so that would be 5/15 minus 3/15 or 2/15 pi. All right, so not too difficult on that one. I'm going to do the next one from start to finish. I have no graph here. We have nothing but the problem. We want to find the volume of the solid of revolution formed by rotating the finite region bound by the graphs of y equals the square root of 2x and y equals 4x squared. So first step, I'm going to draw a coordinate plane there. I don't really need to have values on it because I'm not going to put them on there. So y equals 2 times the square root of x. So it's the same as y equals the square root of x, but it's horizontally shrunk. All right, so if I plug in 0, I'm going to get 0. If I plug in 2, if I plug in a half, right, I'll get 1. And if I plug in 2, I'll get 2, because that'd be the square root of 4, which is 2. So it kind of looks like this. It's good enough. And then y equals 4x squared. All right, so that's going to be just like y equals x squared, except it's going to grow 4 times as fast. So I'm going to have 0, 0, and I'd have 1, 4, right? So 1 about there. So it's kind of a fast growing function. So it'll look like kind of like that. And where these two intersect, well, my graph is not well drawn. Let's find our points of intersection, and then we can make sure we graph this well. We see where it graphs at 0, they're going to intersect. I don't see anything, there's no boundaries parts, so let's hope they intersect one more time. Maybe I didn't draw this well. Let me draw this again. I may have drawn one a little too fast. I'm going to draw that one more time. But let's find our points of intersection. Because I think that y equals the square root of 2x is going to grow a little faster just between 0 and 1. And I may not have drawn enough detail to show that. All right, so let's find where they intersect. That may make a better graph. So we have the square root of 2x equals 4x squared. We'll square both sides. So we have 2x equals 16x to the fourth. Move everything to one side, so 0 equals 16x to the fourth minus 2x. We'll factor out the 2x. So I'd have 8x cubed minus 1. So actually, this won't be a very pretty number, because it's going to be the cube root of 1/8. So 0 is 1, but they do intersect, and I didn't show that on my graph. So if something looks wrong, just get your point of intersection and then graph those. Sometimes that makes for an easier graph. So I'm going to have x cubed equals 1/8. Oh no, that'll be nice, because that's a perfect cube. What was I thinking? X equals 1/2. All right, so I didn't draw it with enough detail. They do intersect twice, so I'm going to draw the one graph, and then I'm going to draw the other graph. And if we hone in, right here they'll intersect at 0, 0, and we missed that one. I made it grow too fast, too quickly. We have 1/2. Well, it doesn't care what, I don't care what the other number is, but 1/2 is what I need. And so we're rotating that around, and so the mirror image will be on the other side. I'll just draw it in another color so it's clear that it's a mirror. So it'll just look like, kind of like that, right? And then here's our, got a little cup here. And then there's our washer right there. So we're going around the x-axis. The upper function is the outer function. Right, so that was, I should label those. Oh, it's a good idea to label it so you know which function is which. The blue function here, and color coding is not a bad idea either. Y equals the square root of 2x, and the green one here is y equals 4x squared. I know that's what I did when I learned this stuff. Color coded everything. All right, so, and I like colors anyhow. So now we're going to, when we integrate it, our volume is going to be pi times the integral. And then we're going to have the outside outside or upper function is going to be the square root of 2x squared. And then we're going to subtract from that our inner function, which is the green function there, 4x squared all squared. And that's going to be integrated from 0 to 1/2. And that is a dx. And so there we've got our integral set up. So now you see all the steps. I started to sketch my graph, but sometimes take a moment and find your points of intersection, because that will help you sketch a better graph, because I realized I made a little mistake when I was trying to draw y equals 4x squared. I wasn't making it intersect y equals the square root of 2x, and they intersected. So find your points of intersection, draw your graph, and then set up your integral. And then all you have to do then is integrate and evaluate. So let's do that. So our volume is pi times, I'm going to square, of course, first, 0, 1/2. So the square and the square root will just cancel. So this will be a 2x minus, and then this would be 16x to the 4th dx. And then I'll integrate. So our volume is pi times 1/2. From 0 to 1/2. This would be 2x squared divided by 2. So this is going to be, oops. Well, you know, once I integrate, I don't need the integral signs anymore. Let's put just a parentheses. Got carried away there with integrating, or drawing the integral sign. So this would just be an x squared minus. Right? So this is going to be x to the 5th, then divided by 5. So this will be 16/5 x to the 5th. And we're evaluating that from 1/2 to 0. So our volume is going to be pi, and then 1/2 squared minus 16/5 1/2 to the 5th. And then if I plug in the 0, I'm just going to have minus 0. Okay. So we'll square this, or we'll simplify this. So we have pi times 1/4 minus, this would be 1/2 to the 5th power would be 1/32. I'm actually going to write that down. 16/5 times 1/32. And then we can see that this would cancel here, be 1 and 2. So that's going to be 1/4 minus 1/10. Not that bad. And the common denominator here would be 20. So 1/4 is 5/20 minus, and that was 1/10. So 1/10 is 2/20. So our volume is 3/20 pi. That would be the correct volume for that one. All right. So I hope that one was clear. So here's my example. Rotate with all the steps for finding the solid, the volume around the x-axis. Let's look at a y-axis now. Sketch the region bound by the graphs of the given function for the specified values of x or y, then find the volume of the solid obtained by revolving the region about the y-axis. Right? So this one actually is easier to graph. I can know where this is going to intersect. I have y equals 0. That is the, and I'll draw that. This is just the x-axis there. I'm going from 0 to 4, so because these are going to, they keep on, I could draw an area forever, right? They aren't going to intersect. I'm just going to keep having a line here. So good thing they told us to go from 0 to 4. Y equals the square root of x. We'll draw that one in. So here we go. And we're revolving this direction. I can't point. You can't see me when I point. We're revolving this way because it's around y. If this was around x, we wouldn't use the washer method at all. We would use the disk method because it's flush right against, it's a little crooked there. This blue one is supposed to be at 0, 0. It's flush right against the x-axis, but it's not flush against the y-axis. So here we can see, I need to draw it in black, I guess. Green, no, I used green. We'll draw it in black. So right here is our, actually, it'd be nice if it was another color. Let's make it another color. See if I can make it another color. Property, maybe not. Well, you know, I found out I cannot make things other colors when I'm taping. All right, so that's our sample washer ring. That'll be fine. We can see who's the outer and who is it's going to be the inner there. So it's going to go from right to left. Now, interestingly, y equals 0 is not going to be one of my boundary points, right? If I think what's causing the washer, causing me to have a washer here, I've got the black there's the outside, the blue, the green here is the inside. So what's the outside function? It's not y equals 0 at all. That just set up our boundaries. It's actually right over here. It's x equals 4. That's what's forming our boundary. That's the outside function right there. So this is the outside. So tricky, you got to graph it. Sometimes they give you information that was important, y equals 0, because it sets up our shape, but it's not actually part of the calculating out the volume. X equals 4 is. And then the inside one is right here, y equals the square root of x. The only problem is that that's not in the right format. We need to get that in the right format. So we're going to square both sides, so y squared equals x. So this is going to be our inside function, right? Because this one is to the left, and this one here is to the right. So let's set up our integral. We've got our diagram. Our diagram helps us set it up. If we had not drawn a diagram, we would not have done this correctly. And then now we can see what to do. All right, so we have, I'll just put it over, I guess I'll put it over here. And then I'll just move to the other side if I needed to. Oh, and then we need one other thing. We need our boundaries. So let's go find our boundaries. So we know one of them is, right? One of them is 0, 0. 4 is the x. I want the y, not the x. If I plug in 4 for the x over here, y squared equals 4. I take the square root of both sides, and I only want the one in the first quadrant. 2, or y equals 2, is my boundary. So this one is 2. All right, so we're going to integrate from 0 to 2 because it's the y, not the x. All right, so integration limits need to be y values. All right, so, and then our outside, we have 4 squared, right? We have to square it, minus y squared squared. All right, and that's dy. Almost couldn't get the dy in there. I need to move that down just a little bit, piece by piece. All right, so now we can square, and then we'll integrate. So we have, oops, almost forgot something though. Don't forget to draw that in, put that in. Even on the, just the setup, you don't want to not have that pi in there because that would be technically wrong. So we have 16 minus y to the 4th dy, and I'm going to, and that's from 0 to 2, and I'm going to integrate over here. Maybe I'll integrate in another color. So we're going to have 16y minus, let me put my pi in there, volume equals pi times 16y minus y to the 5th divided by 5 from 0 to 2. So our volume here is going to be pi times 16 times 2 minus 2 to the 5th divided by 5 and minus of 0, because a 0 would be 0 for either of those terms. We'll simplify, so our volume is pi times 32 minus 32 fifths. I need to turn that into fifths. So 5 times 32 is going to be 160. So 160 minus 32 fifths is going to give us 128 fifths pi is our volume, and that one's good. I feel like I've done a similar problem, but set up, presented differently. So that's okay, because it was presented differently. All right, so here's this one. I think I've got 2 more and a couple summary pages. Here's my next one. The graph's already drawn on this one. And this time I'm revolving around a horizontal line that is not the x-axis. I'm revolving around -1. Okay? So let's draw the other half of the figure here. I'll draw it in green. So the other half, well, let's see what this is going to look like. And so it's that, of course it's not where I wanted it to go. It's going to go there. Of course it's the wrong size, but this, I think we can still figure it out. And so it'll go from here to here. So kind of a bowl shape here. And we're going to go the left function, the right function minus the left, right? Because we're, oh, excuse me, this one's not vertical, this one's horizontal. The upper minus the lower, right? So our upper function is over here. It's the square root of x plus 1 is our upper function. And then the lower function is formed by y equals x squared plus 1. So this is lower, and this is upper. All right, and now we're not going around 0, we're going around -1. So we're going to have to subtract that out. Do you think it makes the volume less or more? When we think about it, it's farther away than the x-axis was. It's going to make it more. All right, we're going to be subtracting a -1. So that's going to be like adding a 1. All right, so let's set this up. We have our points of integration, I think, are pretty easy to see there. 0, 0, and it's 0 and 1. That's all that really matters. Right? So points of integration, or limits of integration, are x equals 0 and x equals 1, because it's the x. All right, and we can always set them equal to one another and solve. I don't think that's going to be necessary here. I think it's pretty clear from the graph. And of course, if you plug in 0, I get 1 and 1. And if I plug in 1, I get 2 and 2. So, all right, so our integral is going to go from 0 to 1. And my outer function is the square root of x plus 1 squared. And then I have, oops, almost forgot a little piece. And then minus a -1, there we go, squared. And then minus our inner function, which is the lower one there. So x squared plus 1 minus a -1 and squared and dx. Boy, that took me a long time just to write across the line there. I'm going to run out of space. I may have to use the space up above. All right, so let's simplify it and square. So, oops, and then volume is pi times. So volume is pi times the integral from 0 to 1. I'm going to simplify and then I'll square. So I have the square root of x. This is now going to be a plus 2. squared minus, and this is also going to be x squared plus 2 squared. So we'll square that, and square root of x times square root of x, that's going to be x. I've got 2 times the square root of x plus 2 times the square root of x. That's 4 times the square root of x. And then plus 4. And then minus, got to square first. So I'm going to have an x to the 4th plus 2x squared plus 2x squared is going to give us 4x squared. And then a plus 4. So we'll distribute the negative sign, and I'm going to move up here, and I need to write my terms a little bit smaller. I'm going to run out of space. So we have pi from 0 to 1, and that is x plus 4 square roots of x plus 4, sorry about that, minus x to the 4th, and then minus 4x squared, and then minus 4. And we should probably simplify. Minus 4x squared. My shadow is blocking. Minus 4 dx. We haven't integrated yet. And then, well, let's combine some terms. The only thing I see is the 4 and the negative 4. So volume is going to be pi from 0 to 1. X plus 4 square roots. Let me rewrite that. 4 times x to the 1/2. Well, I may have to do this as 2 separate podcasts, but the next one's going to be pretty short. Minus x to the 4th, and then minus 4x squared. Oops, darn it, I wrote one of the 4's in. Minus x to the 4th minus 4x squared dx. Right? I should have only 1, 2, 3, 4 terms, and that's what I have. So we integrate, and our volume is pi times, and this would be x squared divided by 2 plus, that'd be the 3/2. So 4x to the 3/2 divided by 3/2, and then minus x to the 5th divided by 5 minus 4x cubed divided by 3. And we're evaluating that from 0 to 1. It's not that this problem was so long, but somehow I took up a lot of space. And I'm trying to figure out where I'm going to write any more. All right, so our volume is, this would simplify, so we have x squared divided by 2 plus, this would be 8x to the 3/2 divided by 3 minus x to the 5th divided by 5 minus 4x cubed divided by 3. So if I substitute in, I'll switch colors here, my volume is 1, and we forgot this here, is 1 squared divided by 2 plus 8 times 1 to the 3/2 divided by 3 minus 1 to the 5th power divided by 5 minus 4 times 1 cubed divided by 3, and then the rest, if I plug in 0, that's just going to be 0, and that's all times pi. So that is, let's see if we have just a little bit of space. Just a little bit of space to finish this problem off. All right, so this is going to be 1/2 plus 8/3 minus 1/5 minus 4/3. So I could combine those 4/3, and my 30 is going to be my, I don't get any awards for planning my space out well here today. So this would be 15/30 plus 80/30 minus 6/30, and then minus 40/30. Oh, I didn't combine them. I said I was gonna. So that's going to be 1595 89, 49. So our volume is 49, and that's all times pi. 30th pi. There we go. Doot, doot, doot. That's the end of this problem. I think when I post this, I'm going to have to like put a map so you know which way to go. Otherwise, it's confusing. I should have worked top to bottom. Anyway, I'm going to stop this podcast. I have just 3 more slides and then the closing. So I'll just finish those off and that'll be the end of it. Okay, bye.